Alright, class, we're going to cover graphing quadratics from standard form. Last time we graphed quadratics from vertex form. This can be a little bit more challenging, but there's some stuff that you do have from the past that you can use. You know, remember some of your old math. It'll help you remember some of the new stuff. I have three forms of standard quadratic. They're pretty much the same. Y equals ax squared plus bx plus c might be the one you would typically be used to if you're going to be graphing a lot. Y is completely interchangeable with f of x or any function g of x, so these are definitely equivalent. And this one always got me. Why would 0 be equivalent to y? But this is a form where you want to solve instead of graph. So three different versions of standard quadratic form. Here are some of the properties that you need to know, most of which is reviewed from the last section or even beyond. Your a value. Well, the standard quadratic form, remember, is ax squared plus bx plus c, and then equals what? Equals y, maybe. Your a, b, and c, they're just numbers. And a can't be 0, because if a was 0, then this term here would go away, and we wouldn't have a second degree term, and it's a second degree term that makes it a quadratic. So a has to be non-zero, b and c can be any old number, even 0. If a is greater than 0, this is something we had before. It is a U-shape, it's called a parabola, and it opens up. And if a is less than 0, same deal, except for it opens down. The y-intercept is going to be easier to get from standard form, perhaps, than vertex form. It's just going to be this number right here. So the y-intercept is c. In linear form, y equals mx plus b. The b represented the y-intercept. This kind of acted like an A, you know, like we're just adding in an extra letter. So the y-intercept becomes c, and you could tell that by if you plug in x equals 0, then this would go away, because you'd have a times 0 is 0, plus b times 0, still 0, and then plus whatever c is, so your y value would be c. Or if the absolute value is greater than 1, then that's going to make it steep, and if it is absolute value of a is less than 0, that would be numbers like 1/2 or 1/8 or 1/10. The closer that gets to 0, the more wide it becomes. Now the axis of symmetry is something that we did talk about in the last video, and what we got there was it goes through the vertex, but here you're going to get a little bit more information. So maybe the first bit of new information you really got to pay attention to. It's x equals negative b over 2a. So that would be taking this, remember it's a number, and this, and plugging into a function. So for example, if you have y equals 3x squared minus, let's go 4x plus 7. Then to find the axis of symmetry, you plug in a negative from the formula. The b is negative 4. And then all over 2 times a is 3. So I've got the opposite of a negative is a positive, 4, over 2 times 3 is 6, or simplify, x equals 2/3. So that'd be a vertical line, and it would go over not a whole unit, but 2/3 of a unit, and be like that. Pretty bad looking graph, but that's okay, we'll get better coming up. Vertex. This is going to look a little bit strange. The vertex was very easy to find in vertex form, but in standard form, a little bit more difficult. So just like last time, the axis of symmetry goes through the vertex, so your x value on the vertex will be negative b over 2a. And then your y value, remember how y is replaceable by f of x, like I talked about here? These are the same thing. Well, I will just find f of, well, what's x? Negative b over 2a. Hey, Jared, the phone ring? I was just selected for a free cruise to the Bahamas. Exciting, huh? Yeah, I hung up. Alright, so here's my vertex, and we will have an example like that pretty quick. Okay, our first example, graph y equals 2x squared minus 8x plus 6. The first thing we are going to do is find our axis of symmetry. That's going to be x equals negative b over 2a. b is negative 8, so I've got the negative from the formula, the negative 8 from the equation. So total, that's going to be, I could simplify that now, or I could wait, but I'm going to do that now. All over 2 times the formula, and a is another 2. So it's going to be 8 over 4, so that's x equals 8 divided by 4 is 2. So my vertex is going to lie on this line, and just like in the last section of vertex form, once I find that vertex, I am mostly done. So we are going to find the vertex. I said I was going to explain that rather quickly. Here it comes. The vertex is at negative b over 2a, f of negative b over 2a, because x is negative b over 2a. So my negative b over 2a, I already found that. That's right here. X is 2. So what does this mean? Well, that's very simple, actually. We're just going to find f of x, which we can replace the y with an f of x. And if we're finding f of 2, then we just replace all the x's with 2's. So that's going to look like this. Just follow this equation down here. F of 2 is equal to 2 times 2 squared minus 8 times 2 plus 6. 2 squared is 4. 2 times 4 is 8. First term taken care of. Here, negative 8 times 2, negative 16. Bring down this term. Bring both down. So simplify. The negative 8 plus 6 is negative 2. So f of 2 is equal to negative 2. So my vertex is the point 2, negative 2, which is going to be right here. Now, we could make a table, but just remember the A rule. Your set of odd numbers, 1, 3, 5, multiply by A. So A times 1, A times 3, A times 5, and A is 2. So I will have 2 and 6, and 10 will not fit. That's okay. So over 1, up 2. That's that number right there taken care of. Over 1, up 6. 3, 4, 5, 6. That's that number. Said I wasn't going to get this one, then reflect these over. Hey, look at that. Y-intercept at 6. I could have used that instead of the A rule, but the A rule gets me lots of points, not just 2. So then we try to make a parabola, nice and smooth, particularly at the end. Try and hit those points, arrows, and done. My vertex, x equals negative b over 2a, which is negative 4 over 2 times 1 is 2, so that's negative 2. Then plug that back in, and I'll have negative 2 squared. The input is negative 2. That is going to get squared, so negative times a negative. Plus 4 times negative 2 minus 3, and that's going to be negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Notice I'm not saying plus a negative 8. Adding a negative 8 is just like subtract. Minus 3. 4 minus 8 is negative 4, then minus 3. Negative 4 minus 3 is negative 7. So I have negative 2, negative 7. 1, 2, 3, 4, 5, 6, 7. This thing opens up. A is 1, so over 1 up 1. Over 1 up 3. Over 1 up 5. And over 1 up 7. Somewhere up there. I've lost my accuracy. Now we reflect over. 2 away from the axis of symmetry, 3 away from the axis of symmetry, and that's probably good enough. I will come up here a little bit. not too bad. Alright, next one. A is 1/2, but let's see. X equals negative b over 2a. Alright, a is 1/2, so 2 times 1/2 in the denominator. Don't freak out. 2 times 1/2 is actually really easy. It's just 1. So we'll be dividing by 1. So just the numerator counts. So negative b is going to be negative 2. So x equals negative 2. Hey, has the very same axis of symmetry. So we'll add a little blue here. And then we plug that negative 2 back in. 1/2 times negative 2 squared plus 2 times negative 2 minus 3. Negative 2 times negative 2 is 4. 4 times 1/2 is 2. And then I've got 2 times a negative 2 is negative 4. So just like last time, I'm just going to go negative 4. Bring down the negative 3. This time, instead of adding straight across, because order of operations says so, I am going to add negatives first. Negative 4 plus negative 3 is negative 7. 2 minus 7 is negative 5. So my vertex is at negative 2, negative 5. So right here. Then A is 1/2, so I'm going to go 1, 3, 5, and then multiply by 1/2 each time. 1/2 of 3 is 3 halves, and 1/2 of 5 is 5 halves. So I'm going to go over 1 and up 1/2. I'm going to go ahead and reflect now. I'm going to go over 1 and up 1 1/2. It's got the same y-intercept. Look at that. Same y-intercept. Could have known. Okay, so 2 away, 2 away. Gives me another point that's a duplicate right there. And then one more. Over 1 and up 2 1/2. 1, 2 1/2. Why did I say 2 1/2? Well, 5 halves is 2 1/2. And we got it right here. So this is just going to come out to be wider than the purple graph. But we could have known that too without much thought, because this is a number between 0 and, well, actually between 1 and negative 1 is going to make it wide. Between 0 and 1 is going to make it wide and open up. What is my function? How about f of x is equal to 3 halves x squared plus 6x plus 4. So the max and min part, well, that's easy. It's all about this. But you know what? Sketch something like this. At least just sketch that it goes and opens up. So that means that it's got a minimum value. That minimum value I missed by a little bit, but that minimum value is going to be, the y value right there. So my answer to what is the maximum or minimum is going to be that coordinate of this point of the vertex. So does it have a maximum or a minimum? The answer is it has a minimum because it opens up. And then I plug everything back in, find the vertex. It's pretty much just like the last two examples, except for I'm not so much interested in the graph, but in the top point, or the high point or the low point, the vertex basically. So I am going to go x equals negative b over 2a, which is going to be negative 6 over 2 times 3 halves. Again, don't freak out. 2 times 3 is 6. 6 divided by 2 is 3. So the denominator, it's just 3. I could have done it another way. I could have canceled those out. So I've got negative 6 over 3, which is negative 2. So my x value is negative 2, and then I plug that back into this function. So the point negative 2, negative 2. So my answer is where it has a minimum, and that minimum is negative 2.